Question 5. The diagram shows the speed time graph for part of a journey for two vehicles, a car and a bus. I calculate the acceleration of the car during the first 18 seconds. So this is the acceleration of the car during the first 18 seconds. So we have this is 14. From here to here is 14, and then this is 18. So the acceleration is 14 over 18. All right. In the first 40 seconds, the car traveled 134 meters more than the bus. Calculate the constant speed v of the bus. So we're going to find the area under the ship. For the bus, we have, it's a rectangle. From here to here is from here to here is v, and the length here is 40. So for the bus, for the area under the ship, the area is 40v because it's a rectangle and the area is length times breadth. Then car, for the car, this is the area. I have to clean this so it to be clear. For the car, I have this entire area, this side. So if you look at the shape, it actually looks like a trapezium. However, you can decide to cut out the shape. So I have one shape here, I have two, and I have three. So we're going to find the area of all the shapes. The first one is a triangle, and the area is half base times height. The base is 18 and the height is 14. So that's the car now. I have half times base is 18 and the height is 14, plus for B, for shape 2, that is a rectangle, the base will be 40 minus 18, and that's 22, while the length would be this entire side, which is 24. So we have 22 times 24 plus shape 3. For shape 3, we have also a small rectangle. This is 18. The length is 18 and the breadth is 10. And that's 18 times 10. So let's solve this. If we solve this, we would have 126 plus 528 plus 180. Let's see, 126 plus 528 plus 180, and that will give us 834. Now see the relationship between the distance traveled of the car and then of the bus. The car traveled 134 meters more than the bus. So that means the distance traveled by the car is 134 more than the distance traveled by the bus. So we collect like terms equals to 40v. So if we subtract this, this would give us 700. So we have 700 equals to 40v. We divide both sides by 40, divide both sides by 40, and our v would give us 17.5. So v is 17.5 meters per second. B. A train takes 10 minutes 30 seconds to travel 16,240 meters. Calculate the average speed of the train. Give your answer in kilometers per hour. So since we're given an answer in kilometers per hour, A train takes 10 minutes 30 seconds to travel 16,240 meters. Calculate the average speed of the train. Give your answer in kilometers per hour. So, since we're given an answer in kilometers per hour, we can as well change this to kilometers. 16,240 to kilometers, that means you have to divide this by 1,000. And this will give us 16.24 kilometers. Then we change this to hours. First, we need to take everything to one unit as 10 times 60 plus 30, and that will give us 630 seconds. So 630 seconds to hours will be divided by 60 times 60. When you use your calculator to do this, that's 630 divided by 3,600. That will give us 0.175 hours. So the average speed is 16.24 divided by 0.175. 16.24 divided by that would give us 92.8 kilometers per hour. All right, so we move to question 6. 6a says we should solve 4x plus 15 equals to 9. So this is 4x equals to 9 minus 15. And 4x is equals to minus 6. Divide both sides by 4. X equals to minus 3 over 2. 6b, factorize a square minus 9. That's difference of two squares. That's a plus 3 and a minus 3. Question 6c, write this as a single fraction in its simplest form. So this is 4a over 5 multiplied by 10c over 3ad. So we start reducing. 5 here 1, 5 here 2. Let's see, is there any other thing that would go? No, nothing else. So we have 8c over 3d. So the answer is 8c over 3d. That's the final answer. Then we move to D. 5 raised to power n plus 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 5 raised to power n equals to 5 raised to power m. Find an expression for m in terms of n. Now this whole thing here can actually be written as 5 times 5 raised to the power of n, because 5 raised to the power of n is being repeated 5 times, and this is equals to 5 raised to the power m. Using your knowledge of indices, this is 1 plus n equals to 5 raised to the power m. So we can say that m equals to n plus 1, or 1 plus n, still the same thing. Number 6e, solve by factorization. 4x squared plus 8x minus 5 equals to 0. So we have 4x squared plus 8x minus 5 equals to 0. So we multiply the first and the last terms. This will give us minus 20x squared. We look for two factors. When we multiply, we have minus 20, and when we add up, we have plus 8. So let's see. We have 10 and 2 plus 10 and minus 2. So let's see if that will work. Plus 10 times minus 2 would give us minus 20. Plus 10 plus minus 2 would give us plus 8. So that will work. So we have 4x squared plus 10. Remember, you have to put your x here. Plus 10x minus 2x minus 5 equals to 0. So we do this. Remember, the question says solve by factorization. So we can't use any other method. 2x is common here. We have 2x plus 5 left. Minus 1 is common here. We have 2x plus 5 left. So this is 2x plus 5 equals to 0. or 2x minus 1 equals to 0. So from here we have 2x equals to minus 5 and x equals to minus 5 over 2. So this is minus 5 over 2. While from here we have 2x equals to 1 and x equals to 1 over 2. So the answers are x equals to minus 5 over 2 or x equals to 1 over 2. 6f. Y is directly proportional to x plus 3 raised to power of 3. When x equals to 2, y equals to 13.5. So for this, we have y is directly proportional to x plus 3 raised to power of 3. So y equals to k x plus 3 raised to power of 3. When x is 2, y is 13.5. 13.5 equals to k. 2 plus 3 is 5 all raised to power of 3. So 13.5 equals to 125k. So we need to find the value of k. Divide both sides by 125 and k equals to 13.5 divided by 125. That's 0.108. So that means the formula is y equals to 0.108 into brackets x plus 3 raised to power of 3. So we asked to find x when y is 108. So this is 108 equals to 0.108 x plus 3 raised to power of 3. Divide both sides by 0.108. 0.108. So that would give us 1000. So 1000 equals to x plus 3 raised to power of 3. So we'll find the cube roots of this. When we find the cube root of 1000 is 10. So 10 equals to x plus 3, x equals to 10 minus 3, and x equals to 7. So x equals to 7. FII. G is inversely proportional to the square of D. So we have this, and G equals to K over D square. Now when D is halved, the value of G is multiplied by a factor n. So we have the value of G is multiplied by n equals to K over D over 2 squared. So we have ng equals to K over D square over 4. Ng is 4k over D square. So for us to find n, we need to divide through by g. So 4k over D square divided by g. Now remember g is this. G is k over D square. So n equals to 4k over D square times D square over k. So D square will cancel out, k will cancel out, and n is 4. 6g. Expand and simplify. 2x plus 3, x minus 1, x plus 3. So we can multiply 2 first. So that would give us 2x squared minus 2x plus 3x minus 3. And this would give us 2x squared plus x minus 3. So we can then combine this with x plus 3. So when we multiply this, we use x to multiply everything first. We have 2x raised to the power of 3 minus plus x squared minus 3x. Then we use 3 to multiply everything. We have 6x squared plus 3x minus 9. So we combine everything and write in the proper form. 2x raised to the power of 3 plus 7x squared. This will cancel out minus 9. So the answer is 2x raised to the power of 3 plus 7x raised to the power of 2 minus 9. And the last question for question 6 says Find the derivative, the y dx of y equals to 3x squared plus 4x minus 1. So dy dx is 6x plus 4. That's 6x plus 4. Question 7. Calculate the angle QPR. Calculate the angle QPR. Remember that the alphabets in the middle carries the angle. So QPR, this is what we're looking for. This is small letter P, this is small letter R, and this is small letter Q. So since we have three sides given and we need one angle, so we're using cosine rule. So we have P square equals to Q square plus R square minus 2QR cos P. So that's 38.2 square equals to 39.4 square plus 46.5 square minus 2 times 39.4 46.5 cos P. So this would give us 38, okay, no, let's solve this. 38.2 square, 38.2 square would give us 1459.24. 39.4 square plus 46.5 square is 3714.61 minus 2 times 39.4 times 46.5. This would give us 3664.2 cos P. So we'll take this, all of this to the other side. That's 3664.2 cos P equals to, so we have 3714.61 minus 1459.24. That would give us 2255.37. So we divide through by 3664.2. So cos P equals to 0.6155. Then P would give us the cos inverse of that, and that's 52.0. So the answer is 52.0 degrees. The next question there says, find the shortest distance from Q to PR. So we are drawing a line that is perpendicular to PR. So we have this angle 90, and we're looking for this line. Now we cannot use 39.4. We can't use this length because the line here is not dividing PR into two equal parts. So we can only use the angle and the side that we know fully, and that leaves us with angle P and side R. So we use our SOHCAHTOA. This is opposite because that's the side that is facing the given angle, and this side is facing the right angle. That makes this side is facing the right angle, and that makes this side the hypotenuse. So we're going to be using sine. Sine theta equals to opposite, that's what we're looking for, the shortest distance, divided by 46.5. Now what's theta? Remember, theta is our angle QPR, which is 52.0. So sine 52.0 equals to opposite over 46.5. We'll cross multiply. So the shortest distance we're looking for is sine 52.0 multiplied by 46.5. Now for this sign, 52.0, the actual answer is 52.01065. So you can just use the total answer you have on your calculator instead of using the approximated value. That will give you a better answer, or a more accurate answer. So sine of that multiplied by 46.5, this will give us 36.64. 36.64, and that's approximately 36.6, because we are asked to give an answer to three significant figures. Question 7b. The diagram shows a cuboid. Calculate the length AG. The length AG. This is the length AG. Now the length AG is simply that line that is dividing the cuboid into two equal parts, the diagonal of the cuboid. So here is a formula for that. That's the square root of the length square plus the width square plus the height square. So that's square root of 29 square plus 21 square plus 20 square. So 29 square plus 21 square plus 20 square would give us 1682. 1682. So the square root of that is 41.0. So AG is 41.0 centimeters. Now we're asked to calculate the angle between AG and the base ABCD. Now when you're asked to calculate the angle between a line and the base, the first thing you need to do is to find the diagonal of that base. So I have to find the diagonal of this. I have to find AC. So AC is the diagonal of the rectangle ABCD, and that's going to give us square root of 29 square, square root of 29 square plus 21 square. So 29 square plus 21 square would give us 1282. So we're looking for the angle between this line and line AC, the angle between AG and AC, and that is this angle, this marked angle. Ensure you mark your angle, so even if you don't um have your correct answer, you would get partial mark. You might get partial mark for identifying the angle. So this is the angle we are looking for. This is the opposite, and this side is the opposite. This side, this is the right angle. This side is the adjacent. You can as well not even bother looking for AC in this case, because we already have AG and we have the opposite. So if I want to use AG, it's fine. I can just have my opposite and my hypotenuse. That's sine. So I can decide not to use this since I have my AG. So I would use sine theta equals to opposite, which is 20, divided by the hypotenuse is square root of 1682. So theta equals to 20 divided by the square root of 1682. Then you'll find the sine inverse of that. That will give us 29.186. 29.186, which is approximately 29.2. Now using line AC that we calculated before, remember AC gave us the square root of 1282. We can as well use that too if we want to. So we have, in that case, we're going to use the opposite and the adjacent. Opposite and the adjacent. So that would give us tan theta equals to opposite, that's 20, over the adjacent. So 20 divided by the square root of 1282. Then we find the tan inverse of that. We find the tan inverse of that, and it gives us 29.186, which is approximately 29.2. So whichever route you decide to take, it will lead us to the same answer. Number 7C. The diagram shows the positions of a lighthouse L and two ships K and M. The bearing of L from K is 155 degrees and KL is 112 kilometers. The bearing of K from M is 010 degrees, that's 10 degrees, and angle KML is 96 degrees. Find the bearing and the distance of ship M from the lighthouse L. Okay, so we are looking for the bearing and the distance of ship M from the lighthouse L. So let's see. So we're told that the bearing of L from K is 155. The bearing of L from K is 155. So I'm going to extend this. So this is 155. And that makes this 25. Remember also that the bearing of K from M is 10 degrees. So this is also 10 degrees, alternate angles. So altogether, this angle here is 35 degrees. So we're looking for this distance. This is small k. We are looking for the distance between M and L, which is small k. So we have two angles, and then we have two angles, one side, and we're looking for another side. So that means we have to use our sine rule. So using our sine rule for the distance, small k over sine k will be equals to side m over sine m. So side k is what we're looking for, and the angle at k is 35. Sine 35 equals to m is 112 and sine m is sine 96 degrees. So we cross multiply. K would be equals to 112 times sine 35 divided by sine 96. So when you use your calculator to solve that, K will be approximately 64.6. So that's 64.6 kilometers. 64.6. So now the bearing. The bearing of M from the lighthouse. So we are looking for the bearing of M from the lighthouse. So we have this north from here. The angle here is 25 degrees, alternates to this. Then we have 49 degrees here. Some of angles in a triangle. This is 35, this is 96, so this is 49. But we are asked to find the bearing of M from L. So that means from the north of L down to the line that goes to M. So this is what we're looking for. And that would give us 360 minus 49 plus 25. So 360 minus 49 plus 25 is 74. 360 minus that would give us our final answer, which is 286 degrees. So this is 286 degrees. Question 8. AB is a line with midpoint M. A is the point 2, 3 and M is the point 12, 7. Find the coordinates of B. So for M to be the midpoint, it means I'm going to represent my A is 2, 3 And then let's say my B is x2 comma y2. M is the midpoint, which means 2 plus x2 over 2, comma 3 plus y2 over 2 is equals to 12 comma 7. So we compare accordingly. 2 plus x2 over 2 equals to 12. So that's 2 plus x2 over 2 is 12. 2 plus x2 equals to 24, and x2 equals to 24 minus 2, which is 22. So this x is 22. Then we'll do the same thing with 3 and y2. So 3 plus y2 equals to 7. Remember, it's over 2. So y2 equals to 14 minus 3, and that is 11. So the coordinate of B, uh, the coordinate of B is 22, comma 11. Question 8b. Show that the equation of the perpendicular bisector of AB is 2y plus 5x equals to 74. So for the perpendicular bisector, we need to first find the gradient of line AB. So the gradient M1 is now we have our points. A is 2 comma 3 and B is 22 comma 11. For the gradient, we have 11 minus 3 over 22 minus 2. So that would give us 8 divided by 20, which is 2 divided by 5. Now, if this line is perpendicular to this, if the new line is perpendicular to line AB, then definitely the product of the um, gradient should give us minus 1. Therefore, the second gradient would be minus 5 over 2. So, we're trying to find the equation of the perpendicular bisector. We'll use the formula m2 equals to y minus y1 over x minus x1. M2 is minus 5 over 2. Y minus y1 is y minus 7, and x minus 12. Remember, we're talking about perpendicular bisector, so we need to use the coordinate of the midpoint. So we cross multiply. 2y minus 14 equals to minus 5x plus 60. So let's collect like terms. 2y plus 5x equals to 60 plus 14. 2y plus 5x equals to 74. And that's just the same as what we were given. So we'll move on. C. The perpendicular bisector of AB passes through the point N. The N has coordinates 2, n. Find the value of N. So for us to find the value of N, what we have to do is to substitute. So 2y, that's 2n plus 5 times 2 equals to 74. 2n equals to 64. We divide both sides by 2 and n is 32. Move to question 8d. Point A, M, and N form a triangle. Find the area of the triangle. So we're going to write out the point, the coordinate of the point. A is point A is 2 comma 3. Point A is 2 comma 3. Point M is 12 comma 7, and point N is 2 comma 32. So we're going to draw this. For it to be clearer, I'm going to make a sketch. For it to be clearer, I'm going to make a sketch. So I have this. A is 2 comma 3, so this is 2. This is 3. So A is 2 comma 3. This is A. n is 2,32. N is 2, this is 2,32, somewhere around here. That's n. So this is a straight line. Then m is 12.7. So that should be somewhere around here. This is m. So I have my triangle looking this way. It's just a sketch. Um it's not drawn to scale. So remember, the area of a triangle is a half times base multiplied by the height. So this is 32. From A to N is going to be 29. That's 32 minus 3, 29. So the base is 29, and the height is from 12 to 2. That means the height will be 10. So area will be half times 29 times 10, and that would give us 145 square units. We don't know what the unit is, so 145 square units. Question 9. On the diagram, sketch the graph of y equals to sine x for 0 degrees less than or equals to x less than or equals to 360. Now, if you are not sure of how the graph looks like, you can just put some points in between. This is 0. You can have 90, 180, and 270. So you start with sine 0. Sine 0 is 0. So you have this there. Then you move to sine 90. Sine 90 is 1. Sine 90 is 1. Then you check sine 180. 180 is 0. Sine 270 is minus 1. And sine 360 is 0. That's if you're not sure of the shape of a sine graph. You can as well just make a sketch of it this way. And there you go. Solve the equation 5 sine x plus 4 equals to 0. So this is equals to minus 4. Sine x equals to minus 4 divided by 5. So this negative sign here is just to show us the direction. So x is the sine inverse of 4 over 5. The sine inverse of 4 over 5 is 53.13. Now we use our cast. All students take Coke. At this point, sine is positive. Sine is also positive at this point. So we have this third and fourth quadrant with sign negative. So this is going to give us the formula for the third quadrant is 180 plus theta. Or the formula for the fourth quadrant is 360 minus theta. So let's do that. 180 plus 53.13 will give us 233.1. 233.1, and that's our first answer. While the other one will be 360 minus 53.13. 360 minus 53.13 would give us 306.9. So those are two answers. We move to question 10. The length of the sides of a triangle are 11.4 centimeters, 14.8 centimeters, and 15.7 centimeters. All correct to one decimal, please. Calculate the upper bound of the perimeter of the triangle. Now we're told that all of these are corrected to one decimal place. So if it's one decimal place, we have our error to be 0.05. So the upper bound would be, remember the perimeter of a triangle is just adding up all of the sides. So we're going to add up the upper bound of all the sides. This is the upper bound of the first side plus the upper bound of the second side plus the upper bound of the third side. So let's add all of this up with our calculator. 14.8 plus 0.05, 15.7, 0.05, and that would give us 42.05. So our final answer is 42.05 centimeters. Now take note, there's a possibility of students making a lot of errors in this question because some students will probably think that they have to find the upper bound after calculating the perimeter. No, the question says that all of the sides are corrected to one decimal place. So that means you have to take the upper bound of each side before you solve. Question 10b. The diagram shows a circle radius 15.6 centimeters. The angle of the minor sector is 105 degrees. Calculate the area of the minor sector. The area of the minor sector is theta over 360 times pi r square. So the angle is 150 over 360 times pi times 15.6 square. So we use our calculator. 150 divided by 360 times pi multiplied by 15.6 squared, and that will give us 318.55, which is approximately 319 centimeters square. The diagram shows the circle radius r centimeter and minor sector angle x degrees. The perimeter of the major sector is 3 times the perimeter of the minor sector. Show that x is equals to 90 into bracket pi minus 2 over pi. Okay, so we have to first find the perimeter. So this is the perimeter of the major segment, major sector. This is the perimeter of the major sector. That's 360 minus x, that's the theta, over 360 times 2 pi r plus 2r. Then the perimeter of the minor sector is x over 360 times 2 pi r plus 2r. Now we're told from the question that the perimeter of the major sector is 3 times the perimeter of the minor sector. So 360 minus x divided by 360 times 2 pi r plus 2r equals to 3 times x over 360 times 2 pi r plus 2r. So we start solving from this particular point. So this is going to give us 360 minus x over 360 multiplied by 2 pi r plus 2r equals to 3x over 360 times 2 pi r plus 6r. So let's collect like terms. Let me change the color. Let's take this to the other side to meet with this. So we have 360 minus x over 360 times 2 pi r minus 2 pi r times 3x over 360 equals to 4r. Okay, so from this point, the LCM is 360. 2 pi r is common. I have 2 pi r into bracket 360 minus x minus 3x equals to 4r. Remember, we are looking for x. So from this point, From this point, we have 2 pi r into bracket 360 minus 4x equals to 1440 r. From this point, I'm going to factorize further. 4 is common to this, so this will be 8 pi r into brackets. If I divide 360 by 4, that's going to give us 90. So 90 minus x equals to 1440 r. So we divide through by 8r, divide through by 8r. So pi into bracket 90 minus x would give me 1440 divided by 8 is 180. All right. So remember we are looking for for x. So make sure as you're calculating, you do not lose sight of what we are looking for. So this is 90 pi minus pi x equals to 180. So I have from here 90 pi minus 180 equals to pi x. So I'll divide both sides by pi for me to have my x. So my x equals to um my x equals to 90 pi minus 180 over pi. So I can factorize this. 90 is common. I have pi minus 2 left over pi. And this is exactly what we are asked to show. So that's it. We'll move to question 11. This sign that we have here, these two straight lines, actually means the modulus. So 9m square plus 40m square equals to 205 over 2. So from here we're going to have 81m square plus 1600m square equals to, so we square that, 205 raised to the power of 2 is 42,025 over 4. Multiply through by 4 so that we can have a linear equation to deal with. And this will give us 1600 multiplied by 4 should give us 6400. So this is 6400 m square equals to this. If you add up, we have 6724 m square equals to 42,025. We divide through by 6,724. So 42,025 divided by 6,724 would give us 6.25. So the square root of this would be 2.5. So our two values would be plus 2.5 or minus 2.5. Question 11b. OABC is a parallelogram. OA is A and OC is C. P is the point on CB such that CP ratio PB equals to 3 ratio 1. Find in terms of A and or C in their simplest form vector AC. So AC is moving from A down to C. So we move from AO then from O to C. Now AO is moving in the other direction. So that's minus A plus C, and this can be written as C minus A. Now CP is actually going to give us 3 over 4 of A. 3 over 4 of A. So CP is 3 over 4A. OP is from O to P. So we go from O to C, then C to P. That would give us C plus 3 over 4A. OP and AB are extended to meet at Q. Find the position vector of Q. Okay, so let's see. Find the position vector of Q. That means we are looking for OQ. I'm looking for OQ. So we have two different routes we could take. Is either we go from OA then to AQ, or we go from um OC to CP then PQ. Okay, so let's see which one would be easier. If you look at it very well, this route would actually be easier. So we need to find, the first thing we need to do is to find what BQ would be. We're going to consider Q, B, P, A, O as similar triangles. We're going to consider that as similar triangles. That would give us, so with that we can have BP over AO. BP over AO is equals to BP over AO is equals to um, BQ over BQ over AQ. BQ over AQ. BQ over AQ. All right, so let's go. BP is minus 1 over 4A and AO is minus A equals to BQ is what we are looking for, BQ, and AQ is actually going to be C plus BQ. C plus BQ. So this will cancel out. This will also cancel out. So 1 over 4 equals to BQ over C plus BQ. We'll cross multiply. C plus BQ is equals to 4BQ. C equals to 4BQ minus BQ. And C is 3BQ. We divide both sides by 3. So we can say that BQ is 1 over 3C. So BQ is 1 over 3C. So now that we're looking for OQ, we'll go from O to A, then A to Q. So OQ will be equals to O to A plus A to Q. O to A is, let's check, O to A, OA is A, and AQ is going to give us C plus 1 over 3C. C plus 1 over 3C, and that's A plus 4 over 3C. So the final answer is A plus 4 over 3C. So let's see if you have, okay. So that's all for October, November 2022 paper 4-2. So I hope you're able to pick one or two things from what we have done today. Thank you for stopping by. Thank you for listening, and thank you for watching. Please do not forget to subscribe and also click on the notification bell so that when we drop a new video, you'll be among the first set of people to get to know. Also, don't forget that you can request for a particular paper to be solved. It could be Cambridge IGCSE or checkpoints. It could also be WIEC. It could as well be a new topic entirely. So please, you can put that in the comment section. We'll be glad to help in any way possible to make sure you achieve that success in your external examinations. All right, thank you. I'll see you in my next video. Bye for now.